Now on day 2 of trig identities, we're going to show you some strategies that you can use when you get to some of the more complicated versions of these problems. Okay, the first one we see is, or the first two that we're going to look at are factoring versions. Okay, you'll notice that in our problem, we have two terms in our whole expression, secant times tangent squared, and then the second part is plus secant. Okay, what you should also notice is that both of these terms share a secant. So what we can do is take out a greatest common factor of secant. If we do that, we're left with tangent squared, plus if you divide secant by secant, you get 1. All right. This also shows us that with tangent squared plus 1, we have a trig identity, a Pythagorean identity. And tangent squared plus 1 is also equal to secant squared times secant squared, or just secant, sorry. If we multiply through this, you're going to get secant cubed theta, and that would be your answer. You'll notice that in this case, we didn't turn things into terms of sine and cosine because we recognized something else was going on. Now you could do that, where you put all this stuff in terms of sine and cosine, but then you'd be dealing with much harder fractions, and it would be much more of a complicated with many more steps problems to it. We can show you that another time, or maybe during the Zoom session, but we're not going to get to common denominator problems until down here. So we're going to put that off for right now. Okay, but that brings up a good point. There are sometimes more than one way to do these problems, and it's not necessarily one way is right and one way is wrong. It's just a different steps that you're taking to get to the same place. Okay, but that's really why it's important that you're showing your work of what you're doing so that I can understand what your thinking is and see your logical progression from one step to the next. And number 2. Now this already has a greatest common factor that you've taken out, a secant, but there's one more. On the inside of the parentheses, you have a cosine and cosine cubed. Well, since there's 2 cosines there and one in each part of the term, you can take one out. So I'm going to put the secant still there. I'm going to take a cosine out, and I'm going to put in the parentheses what's left over. So cosine divided by cosine is 1, minus cosine cubed divided by cosine is cosine squared. Now you should recognize that 1 minus cosine squared is a Pythagorean identity, which gives you sine squared. And then secant and cosine are reciprocals. So if we have 1 over cosine from the secant and cosine over 1, oops, that went a little too far, times the sine. These cosines will cancel, and we're left with sine squared of theta, which would be our answer. Okay, so that's using a greatest common factor or factoring types of properties in some of these problems to solve them more efficiently. All right, another thing you're going to see when you're doing these problems is common denominators. Some of these things become fractions when you become 1 over something, or sine over cosine, or cosine over sine. And if you're combining them using adding or subtracting, you need to find common denominators. So we're going to show you how that works in these problems. With secant, we're going to change this to 1 over cosine. Minus, sine stays the same. I'm going to put a 1 underneath it just for the heck of it. And then tangent is sine squared, or sorry, not sine squared, just sine over cosine. Okay, the right-hand side of our problem, when we have sine times sine, gives us sine squared. The cosine gets multiplied by 1, and remains cosine. And then 1 over cosine is still over here. Why did I put squared? I don't know why I keep doing that. Now you'll notice that these two denominators are the same. In order to combine fractions that have denominators in them, obviously, you have to have the same denominator, a common denominator. Since they are the same, they are common, we can combine these two things. So we get 1 minus sine squared on the top over cosine on the bottom. You should recognize that 1 minus sine squared is a Pythagorean identity, which gives you cosine squared over cosine. And then one of these cosines can cancel with one of them at the top, and we're left with cosine of theta as our answer. Okay. Number 4. We have sine. Let's keep that the same. Plus cosine. Let's keep that the same. But cotangent is cosine over sine. Okay, on the right-hand side, if we multiply the cosine times cosine, we get cosine squared over sine plus sine. I'm going to put this over 1. In this case, our common denominator is not so common. We have a 1 and we have a sine. Well, that's not common, so we have to make the left side of 1 look like the right side of sine. So in order to do this, we're going to multiply the fraction sine over 1 times sine over sine to make sure that our denominator is sine. So we have sine squared on the top over sine plus cosine squared over sine. Now that the two denominators are the same, they are common, we can combine our fractions. You will get sine squared plus cosine squared over sine. Notice the sign on the bottom in the denominator does not change because when you're adding or subtracting fractions, the denominators do not change, it's just the numerators, all right, when you combine them. Now you should notice that the sine squared plus cosine squared is equal to 1 in Pythagorean identities. We still have sine on the bottom, but that can be converted using the reciprocal identities to cosecant, which would be your answer. Okay, next moving forward, we have secant minus cosine. So we're going to change the secant to 1 over cosine minus cosine over 1. Now these two problems don't have the same denominator, so we're going to multiply the second fraction by cosine to make sure they do have a common denominator. So we're going to get 1 over cosine minus cosine squared over cosine. Now that the denominators are the same, we can combine the fractions. We're going to get 1 minus cosine squared over cosine. Again, looking at 1 minus cosine squared, that is a Pythagorean identity, which gives you sine squared over cosine. Now this is a little more complicated near the end because this looks like it could be done, but there's another step you can also make, which is one that I would want you to see. Okay, the sine squared is really just sine times sine. And the cosine has just got one term on the bottom. So what we're going to do is we're going to combine these two things to make one term of tangent, and the sine next to it is going to stay the same way. And this is where I'd want you to get. Okay. Last but not least, we have cosecant squared minus cotangent squared. So let's turn this. This looks like a Pythagorean identity, but it's not really written technically the right way. But let's show you how to do it using common denominators. So cosecant becomes 1 over sine squared minus cotangent is cosine squared over sine squared. All right, those have common denominators. They're both sine squared, so when you combine them, you get 1 minus cosine squared over sine squared. Now the Pythagorean identity of 1 minus cosine squared is sine squared over sine squared, which gives you just, as they both cancel, 1. Okay, so that is some different ways of looking at these problems where you have common denominators or greatest common factors that you can take out. All right, a bunch of different things. Now again, there are some of these problems you could do multiple different ways. It would still end up with the same thing. It just maybe take you longer to get there or maybe even shorter to get there. It just depends on the problems you're doing. All right. Again, it's very important you work on the practice sheet and then ask questions about things and get help if you need it. All right.